So good evening everyone. So let us now continue what we have discussed on rad physics earlier this afternoon. So next topic would be the Pauli exclusion formula. So Pauli exclusion formula, so ang ibig kong sabihin nito is it will determine the number of electrons sa bawat shell. So yung Pauli exclusion formula po is the 2n squared. Ito po yung mag-determine kung ilan lang po ang electrons na pwedeng ilagay natin sa isang shell. So, halimbawa sa K-shell, dapat 2 electrons lang pwede. Hindi pwedeng 3. Sa L-shell, dapat 8 electrons lang. Hindi pwedeng 10. So, yun po yung pinaka-maximum. So, pwede kung kulang siya, pero hindi pwedeng sumobra siya. So, yan po yung purpose ng Pauli exclusion formula. So, the formula is 2n squared. N refers to the number of shells. For example, we have a K shell, so it is numbered as 1. L is numbered as 2. So, we have here K, then 2, substitute, then N, the number of shells, so first shell na siya. Then, we will compute. So, 2 here, which is constant. And then the N here, for number of shell, then square. So, 1 times 1 is 2. And 1 times 1 is 1. And then 1 multiplied by 2 is 2. So, ibig sabihin is 2 electrons lang sa K shell ang pwede. Next, sa L shell. So, same process pa rin tayo. So, 2 here. Then the N. So, since it's the second shell, so we have 2. So, 2 times 2 is 4, times 2 is 8. So, meaning in L shell, we have maximum of 8 electrons. So, naintindihan po ba? So, we will substitute that sa succeeding shells pa. M, so it's the third shell. So, 3 times 3 is 9. 3 times 3 is 9 times 2, which is 18. So, and so on. So, we simply substitute hanggang kung ilang shell ang pwede sa iisang electron. So, depende po kung ilang electrons meron ng isang atom. So, for example, kanina, yung cobalt, we have 27 electrons. So, mag-a-add po tayo hanggang makakuha tayo 27 electrons. So, to make it understand more, ito po yung example natin. So, determine the number of shells para malaman natin kung ilang shell meron ng carbon and the number of electrons sa last shell. So, solution, we will look for carbon sa ating periodic table of elements. So, it is 12, 6. So, 12 is the atomic mass or the mass number and 6 is the atomic number. So, 6 also represents the number of protons, and ito din yung 6 ang number of electrons. So, ayan po siya, 12 is the atomic mass or mass number, which represents the number of nucleons. 6, atomic number, also the number of protons and the number of electrons. So, I hope you still remembered what we have discussed earlier kanina. Okay? So, based on this figure, there are 6 electrons. Because 6, so we have 6 electrons. Now, let us determine the number of shells using the Pauli exclusion formula. So, sa K-shell, sabi, 2 na pwede. So, 6 ang kailangan natin. So, let's add more. Sa L shell, yung maximum natin is 8. Di po ba? Because remember, di ba 8 yung maximum natin sa L shell. Pag nilagay tayo ng 8 dito, halimbawa, maximum natin is 8 sa L shell. Kung naglagay tayo ng 8, so 8 plus 2, 2 dito, then siya galing yung 2. So, magiging 10. So, we have 10 electrons. Pero, ang ating pong element is carbon. And in carbon, we have 6 electrons. So, ilan electrons po ang pwedeng i-add natin sa 2 to make it 6? So, di ba 4? So, 2 plus 4, 6. So, we have now 6 electrons. So, this is 1. So, sabi natin, maximum na po yung A. So, pwedeng kulang, pero hindi pwedeng sumobra. So, gets po ninyo? So, ang function po is number of shells. So, we have 1, 2. Now, we have 2 shells. So, meaning, in carbon atom, there are 2 shells. And the number of electrons on the last shell is the last shell 4. So if we're going to draw, so we have this, for example, this is the nucleus. Then we have the electrons. So we will change the color to make it more understandable. So these are the electrons. Dalawang electrons sa K-shell. Dito we have 4. 2, 3, 4. So, ito po yung representation ng ating ginawa. So, yung dalawang shell, ito po yung 1, 2. Then yung shell, ito siya sa K-shell. And then yung 4, ito siya sa L shell. So, naiintindihan po ba? So, again, number of shells of carbon. So, 2 shells, K and L shell. Number of electrons on the last shell. So, we have 1, 2, 3, 4. So, yan po yung sagot sa ating question. So, I hope clear po siya. So, another example po para mas maintindihan po natin. Number of electrons, 6. So, since it is stable, the number of protons is also 6. Number of neutrons, so we subtract A minus C. So, this is A, this is C. So, number of neutrons, so the formula is A minus C. So, tandaan niyo ba ito? Yung kanina, yung diniscuss natin. So, 12 minus 6 is 6. Ito po siya. So, from here, let's bring it here. Okay, number of neutrons is 6. Number of nucleons, ito po siya. Nucleons is nucleons. So, nucleons represents the So, nucleons represents the number of protons, again, as we have discussed earlier, plus the number of neutrons. So, a protons is 6, neutrons is 6, nucleons is 12. Number of shells, so we have K and L, so 2 shells, number of electrons in the last shell is 4. Okay? So another example, determine the number of shells of the cobalt atom and the number of electrons on the last shell. So again, we will look for the element cobalt in the periodic table of elements. So we have this, atomic mass is 60, atomic number is 27. So based on the figure, so we have now 27 electrons. So we have 20, so we will change the color. So we have 27 electrons here. Now we will determine the number of shells using the Pauli Exclusion formula. So K shell is 2, L shell maximum is 8, now we have 10. M shell maximum is 18. If we are going to write here 18, so 18 plus 8 is 26 plus 2 is 28. So 28 po siya, so hindi po pwede, this is 28. 27 na po yung kailangan natin. So what we are going to do is change this into 7. So 17 plus 8, 25 plus 2, now we have 27. And much better po. So number of electrons, we have 27. Number of electrons, we have 27 here. So 27 here. Then we have number of protons, also here 27. Number of neutrons, so we subtract. So A minus C. So 60 minus 27 is 33. Number of nucleons from here. Number of shells, so we have 3. So that's K. 2. L is 8 ang maximum. M is 70. So a total of 27. So number of shells we have 3. Number of electrons in the last shell. So M is the last shell, so we have 17 electrons. So I hope clear po siya. We will proceed. So for the models of atoms, so actually there are several scientists who developed several models of atoms, but we will only discuss here the most important, the more important, prominent scientists that formulated several models of atoms. So the first one was by Dalton. So elements, according to him, can be classified as two integral values of the atomic mass. So Dalton basically formulated the hook and eye model. So this is how the hook and eye model look like. So according to Dalton, so ang itsura ng ating atom is like a hook and eye. Next is by Dmitri Mendeleev. So if the elements, according to him, are arranged in order of increasing atomic mass, repetition of similar chemical properties occur. Ang sabi ni Mendeleev, pag-arrange natin ng mga chemical elements sa ating periodic table is depende po sa mass, so marami po ang magkakapareho. Kasi maraming elements na pareho ang kanilang mass. So, yan po yung theory in Dimitri Mendeleev. And the most notable work by Dimitri Mendeleev was he developed the first periodic table of elements where the elements are arranged according to their ascending atomic number. So the atomic number of an element is distinct to that certain element. So for example, 1 is hydrogen. Wala na pong ibang element na may atomic number na 1. So 2 is helium. So wala na rin pong ibang element na yung kanyang atomic number is 2. So when we say atomic number of 2, automatic helium 2 yan. But for example, we say 60, cobalt 60. The mass of cobalt is 60. Meron din pong ibang element, ang mass ay 60. May nickel and may iron. So meron po hindi lang po yung dalawa. So ang theory po ni Dimitri Mendeleev is the first periodic table of elements where he arranged the elements according to its ascending atomic number. Next by Joseph John Thomson. So he is commonly known as J.J. Thomson. So Thomson discovered electrons. Electrons, according to him, were an integral part of all the atoms. So, kailangan may electrons daw, at may electrons talaga sa lahat ng uri ng atoms. So, the model of Thomson was plum pudding. So, with the plums representing the electrons, so here are the electrons, while the pudding is the orbits. Sorry. Next, by Ernest Rutherford. So, he introduced the nuclear model. So, according to him, atom contains a small, dense, positively charged center surrounded by a negative cloud of electrons. So, ang kanyang focus naman is yung nucleus. So, sa Thomson, ang focus niya is yung ating electrons. According to Rutherford, the center of the atom is called the nucleus. So, ito po yung theory ni Ernest Rutherford. Then lastly, by Niels Bohr. He improved Rutherford's description of an atom. His model was a miniature solar system. He is responsible for the present model of an atom. Yung ginagamit natin model ng atom ngayon is gawa po yan, o na-develop po yan ni Niels Bohr. So, parang miniature solar system kasi nga yung nucleus represents the sun and then the electrons around the sun or around the nucleus represents the planets. So, kaya po miniature solar system. Another term that is also important in our learning of rad physics is the electron binding energy. So what is it basically? So electron binding energy is the energy possessed by an electron in their orbit. So ito po yung energy na tangan-tangan ng isang electron sa kanyang orbit or shell. It is also defined as the strength of attachment of an electron to its shell, kung gaano po siya kalakas kumapit sa kanyang orbit or shell. And also it is defined as the energy required to remove the electron from its shell. So sa board exam po, either po sa tatlong ito yung definition po ng electron binding energy. So usually the same words po siya. So, energy required to remove the electron from its shell. So, ito din po yung energy na kailangan para ma-remove po yung electron na yan sa kanyang shell. To make it more clear, ito po yung ating explanation niya. So, ang tendency po natin is kailangan natin ng electron binding energy sa bawat shell. So, mas malayo po ang electron sa nucleus, mas bababa po ang kanyang electron binding energy. Bakit kamo? Pag malapit po kasi, ito ay positively charged. Ito naman ay negatively charged. So, pag malapit siya, ang tendency is there will be attraction. Since kailangan stable siya, this electron should stay in place. So, in order for this electron to stay in place, kailangan po niya kumapit ng mabuti para hindi po siya ma-attract ng nucleus. Pag malayo naman po, since malayo nga siya, so konti lang din ang attraction between nucleus, which is positively charged, and the electrons, which is negatively charged. So, naintindihan po ba? Okay, again. So, to make it clearer, so sabi ko, sa isang tungsten atom, ang kanyang K-shell electron na electron binding energy is 69.5 keV per minute na electron binding energy. So, sabi ko rin kanina, pag iba po namang element, pag hindi po siya tungsten, halimbawa, pag radium, radon, cobalt, iba rin po ang value ng kanyang electron binding energy. So, iba-iba po yan. So, yun po yung ibig sabihin ng electron binding energy, kung gaano kalakas ang kapit niya dito. The strength of attachment. And another definition kanina is the energy required to remove the electrons from its shell. So, since ang kanyang energy is 69.5, halimbawa, pag may X-ray po tayo dito, ito po yung incident X-ray. May X-ray po tayo dito, tapos gusto niyo pong i-ionize or tanggalin ang electron from this shell, kailangan po ang kanyang energy, ang energy nito should also be 69.5 or greater. Kasi pag halimbawa 69 lang po yung energy niya, hindi niya po ito mariremove. Hindi niya po mariremove ito kasi kulang yung kanyang lakas. Pag naman 69.5, pag magkapareho sila ng lakas, meron pong chance na matanggal ito or ma-ionize ang electron from the K-shell. Pero, halimbawa, pag 70 naman, mas lalong malaki ang chance matanggal ito kasi mas malakas siya. Iintindihan po ba? So, the strength of attachment and the energy required to remove the electron from its shell. Okay? So, I hope that's clear now. Another one are the topics that we have to discuss the nuclear arrangements. So, we have the isotopes, the isobars, isotones, and isomers. So, isotopes, these are the atoms that have the same number of protons, the same element, the same atomic number, and different mass number. So, for example, we have isotopes of barium. So, isotopes of barium. So, the same number of protons, 56. So, meaning, sabi natin kanina, pag ang kanyang atomic number is, halimbawa, 56, automatic barium na po yan. Wala na po limang element na may atomic number na 56. So, 56, so meaning, barium po yan, automatic na yan. 56 na barium. Or 56 ang atomic number ng barium. So, the same number of protons. So, the atomic number, as we have discussed earlier, represents the number of protons. So, we have 56 protons. So, the same element. So, here, the same atomic number, 56, but they differ in mass number. Kasi, for example, yung kanyang mass number is 130, tapos ito 130 din. Ito 130 din. Wala po siyang pinagkaiba. So, they are one and the same element. But with isotopes, different elements, different atomic mass, but the same element, the same number of protons, the same atomic number. Gets po ba? Okay. So next will be isobars. So isobars, these are elements of the same atomic mass. Highlight po yan, atomic mass. So they are different elements of the same number of nucleons. So, sabi po natin, nucleons represents the atomic mass. So for example, we have here the different elements. So iodine, xenon, and cesium. So if you have noticed, iba-iba po ang kanilang atomic number. Kasi nga, magkaiba rin ang element. So ito. So 53 for iodine, 54 for xenon, 55 for cesium. So different elements po sila, but the same number of nucleons or the same atomic mass, which is 131. Okay? Next is isotones. So isotones refers to different elements that have the same number of neutrons. Tandaan po ha, neutrons, hindi po nucleus. Neutrons. So the same number of neutrons. So here, for example, so different po lahat. If you look at it at first glance, magkaibang elements. Iodine, xenon, and cesium. Siyempre, iba-ibang elements, so magkaiba rin ang kanilang atomic number. So 53 for iodine, 54 for xenon, 55 for cesium. Then the atomic mass also differs. 129, 130, 131. So magkaiba po yan lahat. But if you try to solve for the number of neutrons, which is A minus Z, so 129 minus 53, that is 59 minus 30, 129 minus 53. So we have 76. 130 minus 54, so we have here 70. Erase po natin para. So 129 minus 53, that would be 76. 130 minus 54 is also 76. 131 minus 55 is also 76. So you see they have the same number of neutrons, which is 76. So different elements, so meaning different atomic numbers. They have different atomic mass, but their neutrons are all the same. Okay? Then lastly, the isomers. So elements that have the same atomic mass and the same atomic number, but differs in energy levels. So isomers, so technetium 99, also we have here technetium 99 also, because the same atomic number. The same atomic number, 43, so meaning they are the same element. They also have the same atomic mass, 99 and 99, but they differ in E, which stands for energy level, and in this case is represented by small letter m. So the m there represents an extra energy, which is translated as metastable or medyo stable. So metastable, or meaning this element here has an extra energy. So when it gives off its extra energy in the form of gamma rays, so it will now become stable minus this. So basically we have isomers, the same element, the same lahat, but they differ in energy levels. So to make it clear, so the nuclear arrangements, so we have base. Sorry, pain yung pala. So wala po ito sorry. So pain for protons, so the same element because they have the same number of protons, but they differ in atomic mass. A for atomic mass, so meaning different different atomic number, different elements, but the same number of nucleons. The next is N for neutrons. The same number of neutrons, differ in element, differ in atomic mass, and they differ in atomic number. But when you solve for the neutrons, they are all the same. Then lastly, we have the E for isomer. So E for different energy levels. The same po ito lahat. The same element, the same atomic number, the same atomic mass, but they differ in energy level. So isotopes, isobars, isotones, and isomers. Okay? Nagets po ba? So we will stop there and I will upload the continuation of this later tonight. So in the meantime, thank you for listening.